So because B initially was stationary, okay, we have UA is equal to minus VA plus VB. Okay. In fact, the coefficient of restitution formula is obtained from this, but we are not to go through that details. We just want to apply it. Okay. But we obtain that formula from this. So if UA is equal to UB, and we are asked to prove that that's what we are supposed to prove. Prove that VB is equal to 4 on 3 of UA. Okay, then it means we have to eliminate VA. Meaning in our equation, we should only have UA and VB. Hence, we make this as a subject. So let's make VA the subject. Regina, help me make VA as a subject. Regina. Hello, Regina. From this relation, help me make VA the subject.
Please, you send the VA to the left side and bring the UA to the right side.
Okay, so give me the final equation.
You get VA is equal to VB minus UA.
So VB minus UA. Thank you. Perfect. So after making VA as a subject, you substitute this. Let me make this as equation. Let this be equation 3. Let this be equation 4. So this is equation 5. So substitute equation 5 into equation 1. In fact, it can either be equation 1 or equation 2. But the point is that using equation 1 is easier than substituting it into equation 2. And you have to always use the easy way. Take the easy way. Is that okay? But you substitute it into equation 1 or equation 2. But we want to go the easy way. That's why we take equation 2. 1. Lawrence, are you okay? Irene. Oh, Lawrence is not here. So when we substitute equation 5 into equation 1, this is what we have. We have 2 UA is equal to 2 VB minus UA plus VB. Let's expand. When we expand, we have 2 VB minus 2 UA plus VB. Okay. Let's group like terms. UA to the other side of the equation. So we have 4 UA. When we send this to the other side, 4 UA is equal to 2 VB plus VB, 3 VB. Now the outlook is clear. Okay. So VB therefore is equal to, when we divide through by 3, 4 on 3 times UA. And this is the proving required of us. Hello, are we clear? Hello.
Yes, please.
Now, the second question. Calculate the initial velocity of A if B moved at 48 meters per second after collision. So we are to calculate the initial velocity of a UA. If after collision, B moved at a distance of that. So it means that VB is equal to 48 meters per second. And we are to find this UA. So all that we do is to make UA the subject. UA will be equal to 3 times VB divided by 4. So this is 3 on 4 times 48 meters per second. Okay. This is 2, this is 1. So the answer is equal to 36 meters per second. So the initial velocity of A, the initial velocity of A, if B moved at 48 meters per second, would be equal to 36 meters per second. That's the solution to the question. Any question? Okay, I'm giving you 2 minutes to hurry through in writing it, okay? So we can continue. Emerald, hello. No, Emelda, Gloria, Irene, Ishra. Who isn't here? Regina, Rafina, Laurentia is not here. Rafina, where is Laurentia?
Please, I don't know.
Eh, but you are in the same class.
No, this is Trifina from S10.
Ah, okay. Okay. Can I clean the board so we can continue? Can I? Okay, silence means yes. Question 4A. 4A. Irene, state Archimedes' principle. Irene. Hello.
Stay there.
Oh, please, when I call you, don't waste time, okay?
Yes,
Don't waste
please.
time.
Please, when a body is partially or fully immersed in a fluid, so it experiences upthrust, which is equal to the weight of the water displaced.
Weight of the fluid,
Weight of the
okay,
fluid displaced.
display. Good, good. Edita, write any two conditions for an object to stay afloat. Edita, you are giving me one. Emerald, you're also giving me the other. Edita said the ball
Yes, a
rolling.
question again.
You are to give two conditions for an object to stay afloat. Give me one.
Please, I don't know.
Okay, Emerald, give us the first one so we add the other.
The density of the object should be lesser than the density of the fluid.
Okay, Edita, so the first one is that the density of the object must be less than the density of the fluid for a body to stay afloat. Okay.
Okay.
So if you prepare angwamo, angwamo, when you mix oil and water, the oil settles on top of the water, telling you that water is denser than the oil. That is why there is that situation. So for a body to float, one, the density of the body must be less than the density of the fluid. What is the other condition for a body to stay afloat? Yes. Yes. Inshira, take the blessing for us. Inshira,
Please, I'm not sure, but
don't worry. Mhm.
maybe the body should be hollow or something.
Oh, the hollow nature of the body is true, but that also goes into making the body's density less than the density of the water.
Okay, okay.
Okay. Mhm.
Yes,
So that goes into the first one. Let's have Inshira, you were the Samsung, eh?
yes, please.
Okay, Regina, just rejoice. What's the other condition for a body to stay afloat? Regina, are you there?
Yes, please.
We are waiting.
Please, I think the body must be lighter than the object that it's in.
Oh, that also goes into the first one. Okay, about the body's density being less than the density of the liquid. Okay. All right, then Travina, try it. Travina, try.
Okay.
Mhm.
Please, the object must be placed in a fluid that generates an upward force.
It's true, but add more flesh to the bones. Travina, try them more.
Like an example.
No, but add more statement. What you said is true. There must be an upward fall, but something is missing.
Uh, upthrust.
Okay, I think Emelda is ready to add something to it. Okay, Emelda, go ahead.
The weight of the object should be lesser than the upthrust on the object.
Yes, that is true. If the weight of the object is less than the upthrust, the body will just lie flat, as in when you are lying on orthopedic mattress, because of its density, so hard that you can't even uh, push it down, so you lie flat. Okay, so the basic, Emelda, what you said is true, but the basic condition is that yes, either the weight of the body must be equal to the upthrust, or the weight must be less than the upthrust, as you said. Okay, so either the weight of the body must be equal to the weight of the liquid displaced, which is the upthrust, or the weight of the body must be far, far, far less than. Now, when we have a situation where the weight of the body is greater than the weight of the fluid displaced, which is the upthrust, the body sinks. Please, are we okay? Edita, Emelda, and the rest. Please, are you okay?
Yes, please.
So for flotation, we are saying that weight of body must be equal to weight of liquid displaced. Now, weight of liquid displaced is the upthrust thing Archimedes spoke about. So we can also say that weight of body is equal to the upthrust, because this is weight of liquid displaced is the upthrust, as said by Archimedes principle. Now, so if we have equality, the body floats. If this is less than upthrust, in these two situations, body floats. But the moment you have weight of body being greater than the upthrust, then body sinks. Body then sinks. So that's the condition. Are we okay? Are we fine?
Yes, please.
All right. So these are the two main conditions for a body to stay afloat. Two main conditions. So I'll send you a question on this after the class, so that you engage your brains and then forward your solution to me for marking. I think, Irene, I forwarded that to you earlier.
Yes, please. I'll submit it today.
Meaning you haven't submitted. Nice day. All right.
Okay, yeah.
Then B, the question B. If you are done writing, let me know so I could continue. The question B is a practical thing which occurred or happened in Greece. And listen, Archimedes supposedly was asked to determine whether a crown made for the king consisted of pure gold. Legend has it that he solved this problem by weighing the crown first in air and then in water. Suppose the scale read 7.8 Newton in air and 6.86 Newton in water. What should Archimedes have told the king? Take the density of pure gold as 19.3 times 10 to the power 3 kilogram per cubic meter. Ishra, how did you solve this question, Ishra?
Please, I didn't solve the question.
Ishra, you solved it.
Please, I didn't.
Okay. Then, Regina, how did you solve the question?
Miss Nadia, please, I didn't solve that question.
Hey, so who solved that question? Irene, is that you? Who solved that question? Okay, then let's see. You see, the first thing to consider is that, yes, Goldsmith, you claim whatever you used, you made a crown with. was pure gold and nothing else. If that's the claim, then when I determine the density of the crown, since it's pure gold, it must give me the same value as the density of the raw gold. Okay, now the suspicion is actually that, in fact, when he brought the crown felt so light, and so the king suspected that part of the gold given to him was taken and was alloyed. Hence, the lighter weight of the crown. Please, I hope you are with me.
Yes, please.
So that was the king's prime suspicion. Then, if it is the same quantity that was used, then when I conduct or perform an experiment to determine the weight, the density of the crown, it should be close. It should be equal or very, very close to the density of gold. And that is how come they provided the density of gold. That 19.3 times 10 to the power 3 kilogram per meter. Okay, so the motive behind the experiment is that we'll use the experiment to determine the density of the crown, then compare it with the density of pure gold. I hope you are clear with me. I hope you are clear.
No,
Yes,
please
please.
me again.
Okay, I'll take it again. What I'm saying is that if you claim it is the same quantity of gold given that was used for the crown, now if I determine the density of the crown, it must be equal to the density of gold, which is 9.3 times 10 to the power 3 kilogram per meter cube. So as Archimedes, all that I'm going to do is find a way to determine the density of the crown and compare it with the density of pure gold. If the value is close to 19.3 times 10 to the power 3 or exact, you are free, vindicated. Okay, but if the value is far, far, far less than, then I have a bone to pick with you. That's the whole idea behind Archimedes' experiment in this regard. Are we fine? Okay, so let's look at the information. He said, legend has it that he solved this problem by weighing the crown first in air. So the weight of the crown in air. Weight of the crown in air is 7.84 Newton. Okay. Gloria, are you there?
Yes, please.
And the weight of the crown in water. Weight of the crown in water is 6.86 Newton. Now I put it to you. Having weight in air and weight in water, what can we find out of this class? What can we find out of this?
And the upward.
The upthrust. So we can determine the upthrust. So upthrust is equal to 7.84 real weight minus the apparent weight 6.86. Please subtract that and give me the final answer.
0.98.
So 0.98 Newton. Okay. Can we determine, okay, with the upthrust obtained and then the liquid used is water. What What else of the crown can we determine or calculate? Here, I want to pick your views. What information of the crown can we calculate here? Yes. There's the atlas on the crown. With the atlas and the liquid being water, what of the crown can we calculate or determine? Injura. Okay, Gloria, let me put the question to Gloria. The liquid is water. We have the atlas exerted by the water on the crown. Gloria, what of the crown can we calculate?
Mr. Jab, please, the volume,
Volume of what?
the crown.
Volume of water displaced by the crown, which of course becomes the volume of the crown. Thank you. Okay, so please, you see, the same atlas U is equal to, which is, atlas is weight of fluid displayed. And because weight is equal to mass times gravity, we can also say that the same atlas is equal to mass of fluid displaced times gravity. Are we there? Mass of
Yes.
fluid displaced, and this here the fluid is water. So the same atlas is equal to mass of water displaced times gravity. Mass in terms of density and volume, mass is equal to density of the liquid times volume of the liquid displaced times gravity. Okay, now knowing atlas, knowing the density of water, gravity being constant, we can find the volume of water displayed. Volume of water displayed. Please help me in calculating for the volume of water displayed here. Help me to calculate for that value.
It will be atlas over the density times gravity.
So atlas over density times gravity. Put figures together for me and give me the final value. The atlas is 0.9, 0.98. What's the density of water? The density of water. Yes. What's the density of water?
1,000 kilograms per meter cube.
Why not 1 gram per cm cube, Isra?
Why not? Because the atlas is limiting.
Exactly. That's it. And of course, gravity would also be in meter per second squared. So if the quantities are in SI units, then you have to do so. So this must be 1,000. So gravity is also in 10. Thank you for coming. So volume of water displaced, of course, equal to 9.8 times 10 to the power negative 5 meter cube. All right. All right. Now
Yes,
this
please.
volume of water displaced will be equal to what? This volume of water displaced will be equal to yes, and you have to answer. Edita, Emelda, Ishira, Gloria, this volume of water displaced will be equal to
It's the volume of the crown.
why? Why do you think this will be equal to the volume of the crown?
Because the Volume of the crown is equal to the volume of the water.
So whenever a body is fully or partially immersed in fluid, the volume of fluid displaced is equal to the whole volume of the object or that part of the object immersed in the fluid. Okay, so because of this, the volume of water displaced will be equal to the volume of the crown. Volume of crown, therefore, will be equal to, let me adjust the screen. Volume of crown, therefore, would be equal to 9.8 times 10 to the power negative 5 meter cube, because the crown is fully immersed in the. I want somebody think through an assignment I'm giving you right now. In 2 minutes, do it. Help me find the density of the crown. Help me find the density of the crown. How do we determine the density of the crown? If you are ready, please raise up your hand and do the talking for us. Inshira, Amelda, Irene, Gloria, hey, Regina, hey, Trafina, I've forgotten about you. Okay, Trafina,
Yes.
I
Yes,
tried
Mr.
this. Help us determine the density of the crown.
So density is equal to mass over volume.
Yes. Yes, Trafina is true. Okay, times it. So, as he said, density is equal to mass. So, mass of crown divided by volume of crown. Yes, this will also take us there, but I will not use that. This is because I have the weight of the crown in air, which is the real weight. So, because weight is equal to mass times gravity, of course, here having the volume, it is obvious you make mass the subject, okay, divide and then bring it here. That would also do, but there's another alternative. Mass is equal to density times volume. So M is equal to rho V. Therefore, W would be equal to rho Vg. I have the weight in air, which is 7.84. Density of the crown is what I'm looking for. Volume of the crown, I have 9.8 times 10 to the power negative 5. Gravity G is 10. Hooray, I can find the density. So rho is equal to 7.84 divided by 9.8 times 10 to the power minus 4. This is equal to 7.84 over 9.8 times 10 to the power 4. Finish it and give me the final value.
Please, the answer is 8.
So 78,400 divided by 9.8.
Please, the answer is 8,000 kilogram per meter.
8,000.
8,000 kilogram per meter.
Exactly 8,000.
Yes.
So this is the density of the crown. So Regina, if you are Archimedes and you perform experiment, calculation, okay, after your calculation, you got the density of the crown to be 8,000. When the density of gold is 19.3 times 10 to the power 3, what will you tell the king? Regina, what will you tell the king? Regina, I'm waiting for you. What will you tell the king as Archimedes?
Please, I'll tell the king that the density of gold is of the crown is greater than the density of the gold. That means he has been cheated. Or, oh no, the density of the gold is rather greater than the density.
Okay, this is 19,300. If we should multiply this by 2, it will give us 16,000. And this is still not close to the density of gold. So you can be confident enough to tell the king that that guy is a thief. Arrest him. Because your calculation has proven it so. Please, is that okay?
Yes, please.
Yes, that's the beauty of our calculation. So this is a question a lot of you swerved. Irene,
Yeah.
and this is the question you ran away from. Gloria, Emelda, and this is the solution you girls ran away from. When you saw it, you think this is brain twerking, so you won't dare to go near. I think it's an interesting calculation. Please, if you have any question, ask. As I was saying, you can also use the density approach to get the same thing. Maybe you are not clear about using my method. You still want to use density is equal to mass over volume. Okay, then you find the mass of the crown. From here, mass would be equal to weight over acceleration due to gravity. The weight is weight in air 7.84 divided by, we are using gravity value of 10, so 0.784 kilograms. So if this is your mass, then density of the crown would be equal to 0.784 divided